Now, flash floods. So a flash flood is going to be a quick rise in the stream depth. So in the stream stage, right? The stream stage is going to rise suddenly. Flash floods, as the name says it, are usually a fast kind of thing. So it's going to flood, and then soon after that, there's not going to be water up to the stage that it was at before. So usually these flash floods are caused due to intense rainfall throughout a short period of time in a small area. So the stream channels that usually experience these flash floods tend to be small and tend to be fairly well confined. Common places that experience these flash floods are going to be arid environments that are not used to intaking the amount of precipitation that they do during these flash floods. Also, areas that are very steep and with little vegetation to basically soak up the water that is actually infiltrating. And then also happens in upper portions of the drainages, so closer to the edges, closer to the top part where the most precipitation is most likely occurring due to the elevation. So again, those upper portions of the drainages is usually where the main or the smaller tributaries to the main stream are at. Or if you look at it on the longitudinal profile, it's going to be locations near this A point, near the source of the stream itself. Some of you may remember this flash flood that occurred in Boulder, Colorado in September of 2003. I think this flood was actually within the 200 or 300 flood stage. So they had not seen this for, pretty much since ever, since, Western civilization set up here in Colorado. So it was pretty devastating. A lot of people lost their lives, and many properties were definitely damaged. So they can happen. In this case, Boulder is pretty high up in the mountains, so it is common for areas like this to get flash floods. Okay, now we have downstream floods. So we just looked at flash floods. Flash floods are going to be, again, happening at a confined kind of channel that usually tends to be the tributary to a bigger channel. This downstream floods, which are perhaps a better example for that recurrence interval diagram that I showed a few slides ago, this one over here, is going to be more characteristic again of a downstream flood, which happens due to the rise in the tributary depths and hence a rise in the stage of the main stream. So usually these downstream floods cover a very large area. As you're seeing here in this picture, this is supposed to be the stream and how big it usually is. In this case, this was on April 11th of 2004. And then you see that after the flood has happened, that river has easily, quadrupled in width, probably, maybe even more. And so it occupies pretty much the whole floodplain, or close to doing so. So they cover a very wide area. I should clarify that they also happen, as the name says, closer to the outlet of that stream, or at least further away from the source. So if we were to look at the longitudinal length, in this case, the downstream floods occur closer to the outlet. Okay. So they usually are strengthened, or they are caused by storms of very long duration or by saturated soil already. So if you have, for example, a very wet winter where the downstream soils are already wet, and then on top of that you have extra precipitation and extra snowpack, for example, in the mountains, and then in the springtime, once that snowpack is melted and becomes runoff, the tributaries that are carrying that runoff and then feeding the main stream are going to feed all of the water into the stream. And none of the water is going to go into the nearby soils because the soils at the bottom near the stream were already saturated in the first place. So I believe that that is pretty much what happened here in Boise last year. So not this spring, but the previous one in 2017. I believe that is pretty much what happened here, that the soils were already saturated, and then you had extra snowpack and extra saturation, and so you got a little bit of flooding happening. Okay, so it's pretty obvious you got increased runoff, as I said before, and then this is all going to happen due to a combination of all the tributary to the mainstream within the drainage basin, right? It's not the cause of one simple tributary like it was for the flash flood, but it is a combination of the runoff that is coming from all the tributaries in the drainage basin for the mainstream, for the most part. So what happens is that there is a large rise and a fall of discharge at a particular location. So that is pretty common for these downstream floods. You're going to see it again closer to the outlet, and you're going to see a very large rise within the stage. That flood stage is going to increase dramatically. All right, so here in the United States, at least, I know a couple of you aren't from here, nor am I, but you may be familiar with certain areas that are more prone to flooding. As you can see, much of the map of the United States is prone to flooding, however, and you might have experienced it yourself in your home as well. So here in Idaho, at least, you see that we are fairly prone to flooding. This is because we are in fairly mountainous regions, so most of the flooding that we experience is going to be from flash floods. Same here in Oregon and Washington area. Most of those floodings are going to be from flash floods. The same thing is happening down here in Arizona, but not so much because of the mountainous regions. Partly, yes, but also partly because of the arid terrain that they are under. So the soils are not used to intaking as much precipitation, so when they do see high amounts of precipitations, they are gonna have major flooding events. Okay, other places such as the Midwest, for example, experiences a lot of flooding more so than the main parts of the West. So that is because usually they have fairly wet falls in the first place. So the soils are already kind of saturated by the time winter comes. Winter tends to be cold and dry, but obviously it's cold, so no water from the soils is going to evaporate. So once spring comes and there's even more evaporation and runoff from previous snowpack, possibly nearby, then the soils are no longer going to be able to intake any of that moisture, and so you're going to get flooding in the nearby streams. Here in the Midwest also, this is exacerbated due to agriculture. So in agricultural uses, and some of you may be familiar with that, many farmers, what they do is they derail the water that falls into their crops into canals so that their crops don't actually flood, which is very smart. But it can also, damage the flooding areas for the canals or the streams that the canals feed into afterwards. So there's pros and cons to that. But basically, this map kind of shows you the number of floods during time periods of the year. Another important piece of information is that floods were the highest cause of disaster in the US, at least in the 20th century, and I believe they continue to be so if all accounted together. Yeah, and so as you can see, most areas of the US and also of Canada, I'm sad that they don't have a map for Canada as well, but Canada is also very susceptible to flooding, especially pretty much above the Midwest and like Manitoba, Saskatchewan. All of those are very, very propense to flooding. So right here you're able to see, this is from your book, but it shows you selected river floods in the United States in the 20th and some in the 21st century that have happened. And you can see also where they were located, I should say, what time of the year they happened at. So you see that most of them happen sort of earlier in the year, but a few of them happen in the fall or right after, pretty much right after summer, during times where things have been really dry and then suddenly there's high amounts of precipitation. This table also shows you the amount of lives that were lost, and then it gives you the property damage in millions of dollars. Okay, so here you can see the kind of like it's a pretty cool little graph showing you the geographic regions that are at risk of flooding. So the first column is going to give you the number of floods that occur by this continents outlined here. So you see that the greater amount of floods occur in Asia and then in Africa, and then the Americas and Europe are pretty equal. Then the amount of people killed is the next column over. You see that Asia and the Americas have the greatest amount of people killed by floods. Then you see the amount of people that were affected by floods. You see that in this column, the greatest majority is definitely in Asia, and that is probably most likely because of the amount of people that actually live there. So we have said that before, that a natural disaster usually tends to be exacerbated when we add the human factor to it. So it's a natural hazard, or it's a natural event only when there is no human interaction, but it becomes a hazard or a disaster once we add the human factor to it. And then you see the economic loss due to those floods over in the last column. You see that for Europe, that's actually a fair chunk in terms of economic loss whenever they do have floods. Not so much for the Americas in comparison to the amount of people killed. My guess is because of just the type of construction that has been placed in the places where the floods occur. Effects of floods. The primary effects that you're going to have from floods are obviously going to be injury and loss of life, damage to property and infrastructure. That's pretty general to any natural hazard, but more related to flooding itself, you're going to have a bunch of erosion of sediment, which will impact in terms like perhaps the stability of certain buildings that used to rely on that sediment, that were on top of that sediment. And then when you have erosion of that sediment, you will have subsequent deposition of that sediment that may mess things up. So if that sediment is later on deposited next to a road and is completely blocking its way, then that's probably going to be a problem as well. Secondary effects are going to be things like pollution. So if you have, for example, and this doesn't happen very often since they build them with this in mind, but if you were to have a wastewater or a waste waste treatment plant next to a river, say in the 100-year flood stage, then if a flood that big occurred and it carried along with it all the waste, then there would be pollutants further on downstream carried throughout through the river, I should say. Another big secondary effect is going to be disease, is going to be spread. Homelessness, if buildings are again within the floodplain. And then loss of services are very common. In your shoes, I would never really try to touch any sort of cables or anything when you have a flooding. If you haven't lost services, you might potentially do so later. A few factors that may affect the flood damage itself are going to be the land use on the floodplain itself. So what you're using that land for is going to be important, and if you're using it for infrastructure, then you're probably going to see some damage to that infrastructure. The depth and the velocity of the flood waters is going to greatly influence, right? So obviously if it's deeper, meaning if it's the flood stage is higher, then you're going to see greater damage, more likely. And if it's very fast flowing, you might encounter, very fast flowing like flash floods, or it could be lasting for a long time, or it could be, potentially more erosion if it's very fast, or more deposition if it's very slow. So you have a variance there. You're going to see the rate of rise and duration is going to impact also the season. So if you have a flood early in the spring and it's still spring and it's still going to be high precipitation, then that's going to have a big effect on whether you're going to see more damage further on or not. Also the quantity and type of sediment, and we've talked about that before. And lastly, and more importantly to us in this case, is going to be the forecasting and warning of the people and of the community in order to proceed with evacuation. So in the next few slides, that's what we're going to do. We're going to go over the forecasting, warning, and evacuation methods that we have.